Welcome to Brains Matter, the podcast on science, curiosities, and general knowledge. I'm your host, just an ordinary guy. Hey everyone, and welcome to another episode of Brains Matter. On today's episode, I've got Jamali Kagoto, who's been on the show before. Welcome back, Jamali.
Thank you very much for having me again. I'm very excited.
So, for those who haven't heard the interview that you were on last time, could you give us a reminder of who you are and what you've studied and what brings you here today?
Yeah, so I'm Jamali, as was just said. I'm currently still in my undergrad degree at the moment. I'm studying a double degree in mechanical engineering and science, majoring in physics for the science degree. And I'm here because I'm really passionate about most things sustainable development related, and usually try and do a couple projects outside of uni as well. And yeah, I think today I'm talking about one of the projects I sort of started because like a lot of people, I had a lot of spare time last year in lockdown, and wanted to think of a slightly more productive way I could spend my time. So yeah, I just tried to think of a project I could kind of pursue, and yeah, this was the sort of thing that just popped into my brain because I think it was something I first looked at in high school. So yeah.
So, the last time you were on the show, you were talking about some of the sustainable farming techniques within Kenya. So, you've got a strong interest in sustainability, renewability, energy usage, and all that sort of thing, don't you?
Yeah, and I think as I've learnt more about sustainable development, especially I did a program through Monash a few years ago called Green Steps, and that really, yeah, really opened my eyes to quite a lot sustainable development related, and I've just really started seeing how interconnected everything really is, and to properly have a good impact on a lot of these areas, you really need to try and come at things from different directions. And this also just, as I mentioned in the last episode, even just growing up, my family did a lot of stuff in Kenya, and just seeing how things are linked. Like if you can help provide someone food, you'll often see that the kids in that community often start getting better and better grades at school, because they're
Mm.
now more nourished, their brains are working better. And yeah, you really see how interconnected, yeah, a lot of these sustainable development goals that the UN outlined, how interconnected they are. And this was just, yeah, this was just a new challenge. It's a wind energy project, and I hadn't quite looked into this much before. And I just thought this was maybe a new area of sustainable development. I could have a look at what I might be able to do to help out that area.
How did you come up with this idea? Were you thinking, I want to think about some kind of renewable energy resource and work with that, or what was the process that you went through to come up with the idea?
Yeah, actually, this goes all the way back to high school. I had a really incredible science teacher, Mr. Winkler, and this was more of an elective course called Science Extended, and he very much had not really many restrictions on what you could do. One term, he just said, "Okay, guys, create electricity." He doesn't really quite care how. I think some people looked into water wheel, someone was looking into solar. I actually tried looking into creating like a windmill just by magnets though, by having them repel each other. I've eventually found out about perpetual motion, and that didn't work. But it was really,
If you would have cracked that in high school, you would have been a rich
I thought
man.
I was onto something. But yeah, he was very much he very much encouraged curiosity. And then at the end, the last semester I had with him, he just said, guys, do whatever you want. And some of the other teams who were looking into wind energy got me really curious into that. So I thought, how can how can I try and make wind better for for a smaller scale? Like I've seen big wind farms, and I didn't quite know why no one used wind turbines at home. And I was very naive at the time. The version of this idea I did in high school was very, very flawed. But as I sort of learnt a little bit more about wind energy and how it sort of works, and then yeah, I was just trying to figure something out to do last year. So I thought maybe now that I've done most of my engineering degree, maybe I could have a second go at this and see if I can do a slightly better version of that.
So what's the basic premise of your updated version of the
Okay.
idea?
So this is a different model I thought of a house design. One of the things that stops wind turbines from working on a small scale is wind energy has a cubic relationship with the wind speed. So if you halve the wind speed, you get only an eighth of the energy output. And this is really bad in residential areas because you have lots of buildings and trees and stuff. This blocks the wind and slows it down. It also creates quite a lot of turbulence, which makes the wind turbine even less efficient. And I was just looking into these sorts of stats, and in a lot of suburbs, you get wind energy that's about 3 or 4 meters per second. The wind turbines have something called a cut-in speed, which means any speed lower than that, and the wind turbine just won't generate any energy. And for like a small turbine that you might be able to fit on your roof, a lot of them have a cut-in speed of about 3 meters per second. So in residential buildings, you're very rarely getting above the cut-in speed. So I was trying to think how you try and increase the speed of the wind, and I just thought if you can, going back to some fluid dynamics, if you can get the same amount of wind go through a smaller area, it has to pick up speed. So I just started thinking like if you could have a sort of guidance system above your roof and use your roof as a bottom layer. So this way you've got your roof pushing the air upwards, but by having an almost a second roof above that to push the air downwards, it all gets concentrated in the center. And this way it hopefully speeds up the wind quite a lot. And I also added these diagonal walls to try and push it in horizontally as well. So then you get all the wind gets concentrated in the center. And it was, yeah, so it was one way I just thought, especially for people in climates in like Europe, in very northern Europe, how during winter you have darkness for pretty much the entire day. I was like, if someone was there and really wanted their own like renewable energy source to be more sustainable, they really would have no options really because solar is the only one that's practical at the moment. So I thought if we could try and speed up the wind, because the energy a turbine can generate is so heavily reliant on the wind speed. Yeah, I was just trying to look at how I could, yeah, try and increase that speed as it passes over your roof. So as I went back to the idea last year and trying to think how I could improve on what I did in high school, I really first wanted to see that it's something that someone hasn't just outright proven won't work yet. And I found this really interesting paper by a Chinese team in, I think it was 2017. They found that they could increase the wind speed by having a V shape above their roof. In this system, they made that V out of a bunch of solar panels, proving how you could get a sort of hybrid system by using solar panels to increase the wind speed. And these little turbines here proved to be a lot more effective in this system because, yeah, again, the wind speed was increased even just by a small fraction. It was able to produce quite a lot more energy as an entire system, which I thought was really interesting. And I also found this system called by a company called Invelix. Their whole thing was to, yeah, again, just accelerate the wind. So this was for climates where the wind speed isn't quite good. So the wind would come through this big, like 360-degree funnel sort of thing, and they'd pass the wind down and then through a choke point. And as the wind has to go through this small choke point, it accelerated quite quickly. And they were able to get turbines to produce up to, I think, 4 times as much energy as they would if they were just out in the open. So this was really interesting to me to see that there are people looking into similar methods of accelerating the wind to try and create more energy.
That sounds really interesting. So it's about effectively being more effective with the amount of air that's passing through and concentrating in a particular area. So you mentioned that the Chinese team had done some work on that. How does your design differ from theirs in the sense that you said you want to make sure someone hadn't come up with the same kind of idea before? How does yours improve upon what the Chinese design had?
Yeah, so with the Chinese team, they had just the simple V shape above the roof, and then the roof would be acting as like an upside down V, which then pushed the air in. This only works though if the wind was coming perpendicular to the V, so it would be pushed down. if the wind was coming from the side, it would actually get blocked by the pillars that actually hold up the solar panels. So my design hopefully improves on this by being less dependent on wind direction, as I've sort of taken the roof design and spun it 360, so it's almost identical from any direction. The only real difference is the diagonal walls that are meant to push the wind in horizontally. Unfortunately, if the wind's coming on a 45-degree angle to the house, the diagonal walls can't push the wind in horizontally, so you end up getting the wind spread out a lot more horizontally. So the total velocity of the wind is a lot lower, but it still is higher than if the roof system wasn't there. So it still, I think, increases the wind speed by about 20%, which makes the wind turbines would still function almost twice as well as they would in the open. So it is still an improvement, but not as much as if it's coming directly face on with the house.
This works well in a situation where we've got houses in suburbs and things like that. How about in the situation when we're in built up urban areas where you find, especially with cities like Hong Kong or, very densely populated areas like that, where there is effectively a wind tunnel effect in a lot of the apartment style housing. Is there a way that this can utilize that wind tunnel to bring up that increased wind speed?
Yeah, my specific design didn't quite match that because I just didn't have enough time to account for all those variables. But when looking into this, I actually found a concept that was entered in the James Dyson Awards last year, where instead of making the roof this shape, they sort of fit a funnel in front of a wind turbine. And they found that that would be more suitable for an urban environment because there would be less space required. I wasn't able to see their results from their tests, but it did look quite promising. And I have seen some other companies in Europe looking into bringing wind turbines in to urban environments. One of the ways that was one of the pages I follow on social media was sharing a while ago was a company that's actually looking into using the wind from like buses passing to spin these tall vertical wind turbines. So they use highway traffic to create energy through the wind. That was a very cool way you could sort of see wind energy being part of urban environments by just utilizing some of the movement we're already got going to try and convert that into energy.
With your design, how much extra weight or cost would it add to a house? So if I'm someone who's considering building a house with as much renewable capability as possible, if I were to put this kind of design on top of my house to get some wind energy, A, does it materially affect the structural integrity of the house with the additional weight? B, will it cost a lot? And these are the questions you'd be asking as a potential homeowner. And C, if I wanted to put solar panels on top as well, does this make it easier or harder to do that?
Because it was quick again, I didn't quite get to sort of refine the design. So right now probably it is quite bulky and probably would be quite expensive. But the idea behind it of just funneling air in shouldn't actually be that expensive. It might be the cost of maybe constructing a whole roof again. But then with time you'll be able to refine that and make that cheaper. It shouldn't affect solar panels too much, especially because now it's higher. So there will be less chance of like shade from trees and other houses to block the solar. So it could actually improve the overall production of the solar system by just keeping it away from shadows. And as long as the materials used for this system are lightweight, it shouldn't affect the structural integrity too much. Again, that would be a sort of thing that through refinement you'd be able to get some more accurate values of that. Because I haven't quite done the full mathematics behind that just yet. As long as you're using lightweight construction, because it shouldn't be too heavy to be able to push the wind, especially because there's quite a lot of curvature to it. So you're not applying too much of an opposite force to slow down the wind. So the force on the roof hopefully shouldn't be too high, meaning that it doesn't need to be so rigid. As long as the materials are lightweight, you shouldn't have to put in too much bracing for the house, and there shouldn't be too much of a opposing force to the wind because of the curvature. The wind should find it quite easy to flow along the roof line because I kind of tried to use the same shape as airfoil technologies. So the wind shouldn't be pushing too hard against the roof. So it hopefully shouldn't have to be braced too strongly.
So you've got the aerodynamics all worked out.
Yeah, again, it's something that I didn't quite have time to make sure it's the best version of it, but as a proof of concept, it was quite promising. Yeah, so as you can see with this one, because of the curves, the wind doesn't slow too much on approach, which it does end up doing if you have like a flat wall here. You'll see that it actually slows down a lot earlier. This is just because of the force of the roof sort of pushing back on the wind, but because of the curvature, this force is lowered. Again, this isn't the best version of this. It could go through a few more prototypes. But as a proof of concept, the air entering here is 3 meters per second, but at the center here it goes up to 4.7 meters per second, which is quite a large increase in speed. And I think that the average in here is about 4.3. If you just take a 1 meter cube in the center of the system, the average speed is about 4.3, which is still quite a big increase. And I think it will make a wind turbine produce about 3 to 4 times as much energy as it would outside the system. That isn't, to be completely fair, that's not entirely accounting for the amount of turbulence that might be created. Unfortunately, the software I had to work with wasn't great enough to sort of work out how much turbulence is involved to know how much that would affect the wind turbine. But assuming a low level of turbulence, this should be able to make a wind turbine produce 3 to 4 times as much energy as it would outside the system, which is still quite promising.
You mentioned the increase of wind speed to get into the center of the roof structure that you've got here. It would be, I'm assuming, a reasonably compact sized turbine. What amount of energy would you expect that size of turbine to be able to generate on on the roof of a
Yeah.
house?
Yeah, so these would be small turbines that produce in the low sort of kilowatts, so 1 to maybe 5 kilowatts of energy. But you would be able to fit multiple, especially if you're looking at vertical axis wind turbines. You could fit maybe 3 or 4 of them in the center. For larger ones, unfortunately, at the moment, I couldn't quite find space for larger ones in a residential area because they really need a lot more bracing, like to function, because they're quite heavy. But you could fit a few of the smaller scale ones, which are about 1 to 5 kilowatts, and this hopefully will work a lot better because, along with the cut-in speed I mentioned earlier, those wind turbines have something that's called a rated speed, which is the speed that the air has to be going to produce the energy that's advertised. So, like a 1 kilowatt wind turbine will rarely ever produce 1 kilowatt unless the wind speed is above the rated speed. And this doesn't quite get it to the rated speed from just the average wind speed, but it does lower the rated speed by about 60%, meaning you should hopefully be able to get to that max production a lot more frequently than you would currently.
The first thing that I think of with something like this is if we get between, say, 1 to 5, let's take the average of 3. That's generally the amount that most houses with solar panels for an average size roof solar system has as well. So if you had this plus that, you'd be generating 6 kilowatts without too much effort.
Yeah, hopefully. One of the things when I was presenting the full project was talking about how I think this show would have the maximum benefit in hybrid systems, kind of like the Chinese system where they were using the solar panels to guide the wind. I think hybrid systems will help a lot going forward, not only on a small scale but in large scale. Like I don't think our society will go to 100% renewables if we're only using one source. And I just thought this would be a very promising way to bring hybrid systems to a more residential level.
This is all at the proof of concept stage at the moment. So what are your next steps with this?
Yeah, I do want to keep sort of refining it. As as you can see, it's still quite a bulky design, so I'd like to try and get it a little bit lower in size. I do want to hopefully continue this maybe during my honors year, which is next year. because I think it does show a bit of potential that who knows, I'd like to know a little bit more about the practicality of it in real life because I wasn't able to do any physical prototypes because I didn't, in lockdown, it was very hard to find resources to do anything like that. So I would like to do some more physical concepts and prototyping to see how it would actually function in the physical world. And I would also like to investigate the level of turbulence that might be generated and how that might affect wind turbines if they were actually to be installed in the system. But I do think that there's so much room, I think, for the design to be improved because this was a really quick project I sort of did in lockdown. So I think with some more time and energy, it could be refined quite well.
That's a much more productive use of lockdown time than I think most of us did.
Yeah, it was quite a boring first few weeks, and then the International Conference of Sustainable Development sent out the topics they wanted speakers for this year. And one of the topics was how we could make renewable energy more accessible. And then I was like, I can probably put something together for that. And then it was a few months of a lot of cramming to try and get this done on time. But I was very happy with the results by the time I was submitting the project.
Well, I think it's been a really, really interesting and really great idea, Jamali. So when you do get to this for your honours next year, we'd love to talk to you again to see where you've got to with
Yeah,
this.
yeah, thank you. Hopefully, I can get a supervisor or someone to sign on.
Yeah.
But hopefully, I can continue with this project. So it was really fun to look into.
And obviously, if any company out there is interested in supporting you on doing this, you'd welcome
Oh,
that too.
absolutely.
Thank you very much for your time today on the show
Yeah,
again,
thanks again for
Jamali.
having me.
Thanks for listening to the show. You can check out the Brains Matter website at www.brainsmatter.com, and you can find all the other episodes of the show there. There's also other information on the site, such as guests who've been on the show and subscription details. You can also find Brains Matter on YouTube, so make sure you like and subscribe if you're a YouTube listener. If you want to support the show, please consider becoming a Patreon at patreon.com/brainsmatter and signing up to one of the options there. Or you can donate either once off or regularly via PayPal. All you need to do is click on one of the PayPal donation options on the right-hand side of the website. If you have any comments or suggestions, you can leave an entry on this episode's show notes on the webpage or on YouTube, or you can send me an email. All my contact information can be found on the Brains Matter website. The theme music Soul of the Machine was composed and performed by Clive Weeks and is used with his permission. I hope you enjoyed the show. Bye for now.